Hi everyone. Today we see about memory management in operating system, how the data or program are going to be stored in the memory unit. Today we see about the memory unit. So memory management, we have seen how the CPU can be shared by a set of process. That means it is improve system performance, process management. Then need to keep several processes in memory. That means it is going to the share memory, and you can go into various techniques to manage memory. That means it is a hardware dependent. This memory management, what we are going to learn, that means it is a basic memory management. Another one is the virtual memory. So basic memory management, that means it is a logical versus physical address space, protection, contiguous, memory allocation, paging, segmentation with paging. Then virtual memory, that means it is a background, demand paging, performance, page replacement algorithm. That means it is a two kinds of algorithm. That means it is a SCFS, that means it is a first come first serve. Then least recently used, allocation of frames, then thrashing. Next, it is the logical versus physical address space. That is, we are going to see the two address. That means it is going to the logical and the physical address. So logical address generated by the CPU also referred to as virtual address. Physical address is seen by the memory unit. It is an address space. It is a set of all logical address generated by a program. Then physical address space is the set of all physical addresses generated by a program. That means it is a what is resides in the memory. That means it is a multiple process resides in the memory. That means how to going to be allocated to this process in the memory. That means it is the how to protections of memory required to ensure correct operations. So this memory, it is occupy the each process. It is the separate contiguous allocations. That means it is see about the base and the limit register. That means in this process it is contained the base register, and in this process it is the limit. That means it is allocated. It is the 42,940, but it is allocated only limit 12,900. So it is that process only allocated the 12,900 space available. It is a pair of base and limit register. It is defined the logical address space. So in the logical address space, it is defined, it is depends upon the base and the limit register. That means it is how to the hardware address protections with the base and the limit register. That means it is the CPU. So the data it is come from the CPU that going to store in the memory. So it is basically it is depends upon the base and the base limit register. That means this address it is comes to the base register. It is greater than, it is the condition is true. It is going to the base limit register. Address binding, that means the process resides in main memory. So one process resides in the main memory, in the associate each data element with memory address. That means it is the address represented in different ways at different stages of a program's life. That means it is a source code address, usually symbolic. Then compiled code address, that means it is going to be bind to relocatable addresses. That is, it is a 14 bytes from beginning of this module. That means it is a linker or loader will bind relocatable addresses to absolute address. That means it is a 74,000 14, it is the absolute address of the loader and linker. That is the multiple processing of a user program. That means how in the program it is going into stored in the memory. It is the, that means it is the source program. After it is going to be compiled, so the compiler assembler use of the program, it is going to be compiled. It is a compile time. After it is going to the load time. So in the load time, it is based on the linkage editor, load module, then loader. So these three kinds it is going into the load time. So it is the other object module. That means it is after that in the program it is going to be loaded into the main memory. It is a binary memory images. So it is a dynamic linking. So it is going to be link used in the dynamic loaded system. After that it is based on the execution time. So during the run time the memory, the program it is going to loaded into the memory. Then binding of instructions and data to memory. That means the address binding of instructions and data to memory addresses can happen at three different stages. First one is the compile time, next one is the load time, third one is the execution time. So in the compile time, the memory locations known as priori absolute code can be generated. Must recompile code if starting location changes. Next it is the load time, must generate relocatable code if memory location is not known at compile time. Finally, in the execution time, the process can be moved during its execution from one memory segment to another. So that means it is the binding delayed until in the runtime. So it is going to need the hardware support for address map. That means, for example, base and the limit registers. Then logical versus physical address space. So already you can going to be seen what is a logical address. That means it is generated by the CPU. Physical address generated by the memory unit. Then in the logical and the physical address, it is the same in the compile time and the load time address binding schemes. That means in the compile time and load time the addresses are same in the logical and the physical addresses. After that it is going to differ in the address binding scheme. That means it is going to the execution time. So in the logical address space it is set of all logical addresses generated by the program. Physical address space is the set of all physical addresses generated by the program. Next it is going to the memory management unit. That means it is the MMU. That means the hardware device that run time maps virtual to physical address. So many methods it is going to be possible to in the memory management unit. That means to start, that means it is going to the relocations register. When it is going to be that, it is a simple scheme where the value in the relocation register is added to every address generated by a user process at the time it is sent to memory. That means it is a relocation register. That is in the MS-DOS on Intel 80 and 86 used for relocation register. The user program deals with logical address. It never sees the real physical addresses. Say in the logical address it is 25. The execution time binding occurs when reference is made to location in memory. So the logical address bound to physical address. Then dynamic relocation using a relocation register. That means in the data it is come from the CPU and is directly going to the memory. So in between the CPU and the memory, the logical address and the physical address, how can going to be bind? That means it is the logical address it is a 346. Then relocation address it is a 14,000. It is bind into the physical address. That means it is the 14,346. So that means in the memory it is reside into the 14,000. After it is going to be added the 436. It is the relocatable code. That means in the memory, that means in the data, it is going to be allocated in the memory. It is the relocatable code. Next it is going to the contiguous allocation. So contiguous allocations mean each process, that means in memory, in the data it is going to be stored into the memory. That means it is a separated space in the memory. That means it is a contiguous allocation. So each process it is allocated into the contiguous allocation. So in the process it is compared to three value. That means it is the equal the process or less than or equal or greater than or equal. If in the process it is equal that space, it is no problem out that. That means there is correctly it is allocated in the memory. Suppose it is less than or equal to that space, it is remaining space is available in that memory. If greater than or equal to that, the process is not located into the memory. So where is the space it is occupied, the CPU it is going to be such, that means in the memory it is going to be such that where in the process it is going to be allocated. If suppose there is not enough space, it is allocations of that method, it means it is FCFS or LRU based on that algorithm. One process it is go outside, at is the new process it is come to that memory. So this is the contiguous allocations, how in the space or how in the process it is going to be allocated in that process. That means it is a main memory usually divided into two partitions. That means it is a resident operating system usually held in low memory. That means it is a user process then held in high memory. Then each process contained in single contiguous sections of memory. Next one is going to the multiple partition allocation. So it is divided memory into several fixed size partition. Each partition stores one process. Then degree of multiprogramming limited by number of partitions. If a partition is free, load process from job queue. That means it is a multiple partition allocation. Another one is the variable partition scheme. That means in the memory it is a whole, it is available, it is a block of available memory. That means it is a wholes of various size or scattered throughout the memory. So in the memory it keeps the one table, it is keeps the free of memory. That means if each process it is going to be allocated in the contiguous process. If in the process 8 it is out of that, that means the space is occupied that another process. For example, the process 9 it is comes out that place, but it is many spaces available after occupy that process 9. After that in the process 10 it is occupied that space, in the remaining space it is the whole. So in the whole is size is a various size are available. Then in the memory, that means in the table it is keeps the free of memory. That means it is maintain the information about allocations partitions then free partitions. Then how the satisfy the request of size the free of holes means it is a dynamic storage allocation problem. That means it is a first fit, best fit, that means it is a worst fit. That means in the memory it is going to search the where is the space available, that means where is this hole available in the memory. It is the first or top up or bottom up. If the memory it is going to be top up or bottom up of the space, it is a first fit. That means it is the allocated first hole that is big enough. Next it is the best fit, it is allocate smallest hole that is big enough. That means the next it is the worst fit, it is allocates the largest hole. Must also search entire list. Thank you.